This is Josh Mandel with a quick tour of some of the tools that I've been working on for connecting language models to full electronic health record data. And we'll get into the architecture here, which involves one component that's responsible for talking to the EHR using standards, focusing on Smart on FHIR and the US core dataset. Another component in the middle that makes tools available to the language model for working with those Smart on FHIR data. And then a language model or agent which can be driving the interaction with those tools. But before we get too far into the details, let me just motivate this with a simple question, which is to say, what would make it more useful for language models to be able to answer questions like, what medical issues should I be paying the most attention to? So the frontier models like Anthropic's Claude 3.7 Sonnet or Gemini 2.5 Pro and others have a lot of medical knowledge, and they're happy to make some general recommendations, but they are only general recommendations without knowing things like your specific medical history, age, gender, and risk factors. And one solution for sure to this problem is just to copy and paste a bunch of health record data into context. And that would be a simple way for me to inform Claude about who I am and what medical conditions that I might have. And that would certainly improve these answers and make them more tailored towards me. But medical records can get quite big. It can be hard to know what's relevant for answering any specific questions. And where pasting large clinical notes into these models might work quite well, pasting large chunks of JSON data representing structured things like FHIR observation resources, that can be hard for the language model to work with. There can be quite a bit of it, and it's not always the most efficient thing to have the language model reason over these piles of JSON. It's often better to let the language model write code to analyze those piles of JSON. So what I'll be talking through is a few components that live in this GitHub repository called Health Record MCP. We'll talk about some of the details of what the model context protocol is as we dive into it. But to start things off, I'm going to show you the first piece of this pipeline, which is a connector that allows me as a patient in this case to bring my full EHR into this paradigm. But you could think of this same connector as being available for clinician-facing apps that are integrated right into the health record system. So I'm going to start things off by just clearing my local database here and running a command line tool that's going to allow me to create a new database where I'm going to put my whole health record into a SQLite file. And what this is going to do is launch a web server that I can open up in my local web browser here, use this to find my healthcare provider and connect to them. So for me, that's Associated Physicians of Madison. And I'll be able to connect to them using the Smart on FHIR interface that their electronic health record vendor supports. So in their case, this is Epic MyChart, which exposes a way for me to sign in and approve access for an app like this. Totally standard Smart on FHIR flow, where I can pick which patient record that I want to share out of the two that I have access to here. And I also want to call out that Epic surfaces these kinds of privacy risks in the authorization flow based on questions that the app developer has answered. So in this case, I, as the app developer, answered a few questions in ways that would get these little warning signs to light up here. And of course, this is just my app. It's running locally. I'm pulling my own data into it, so I'm perfectly comfortable continuing here and allowing access to the full data set. And then what's going to happen is just right into my local browser, I'm going to fetch all of the US core data set, and that includes structured data as well as unstructured data from clinical notes. And we can see that my data post has been successful. So that means I've now got a new SQLite file on my disk. Just to take a quick look at it, it looks like about 5 megabytes uncompressed. There's a lot of repeat data in there. We'll talk about the format of it in a little bit. But using that data file, I can now run a small server called a model context protocol server that will bring in that data file into memory and make a set of tools available to an EHR. So in my case, instead of using a real EHR, I'm going to use just a language model shell environment. In this case, it's the Cursor application. And I'm going to set up a discussion right inside of Cursor where I'm going to represent this just as a little chat window. And I'm going to have a conversation about my EHR with it. Let's just make a new one here. I'm going to enter it in EHR mode, and I'll just take a quick look at my Cursor settings so you can see what I'm working with. So in this case, I've configured a MCP server, which is just a program that Cursor is going to run for me that's going to load in that josh.sqlite file that we just created. And I can make sure that's running. And now I can have a chat and say something like, check out my EHR and let me know what clinical problems are high priority. So something that requires use of the EHR to be able to answer. In this case, Gemini 2.5 Pro is going to take this goal. It's going to think through different approaches that it could use to answer this, and it's going to decide to call, first of all, one of the tools that I exposed called grep. So in this case, it's looking for any conditions that might mention the word active. So it's using its knowledge of FHIR to look for condition resources that have an active state, and it gets back a kind of plain text rendering of some of those FHIR data, along with references that it can use to track down the full JSON if it needs to. And so in this case, the model has really just asked for a set of structured data here, and it's using that to highlight a couple that it thinks might be the most high priority. Let's go deep on one. I'm going to see if I can get the model to make some more calls to the various tools that are available. So in this case, it's going to call a tool that lets it execute some JavaScript. It's going to maybe try to write some JavaScript, which is an interesting choice here. One thing that the language models are quite aware of is that there's a lot of context in free text notes. But in this case, let's just see what it's looking at. It's having a look at my conditions, looking at some of the related encounters. It's generating a little bit of in-memory summary of these things. And it's going to start creating a timeline. So in this case, actually does a reasonably good job of generating a timeline with these different encounters in it. Let's say, go deep on the clinical notes. And maybe in this case, it's going to decide that it needs to grep through the record and look for some of these notes, which are in attachments. So in this case, it's been able to find a series of notes that matched some keywords here. In this case, post-concussion or concussion. And then it's able to take those notes, synthesize more information from having read them, and start writing up a synthesis for me. And this is now starting to get into real detail where it's able to read the notes that it needs to see just in time. And then we can also just get a sense of how well it can use structured as well as unstructured data by saying something like calculate average over all blood pressures. We'll see if it chooses to write maybe some SQL or some JavaScript to do this based on the structured data. It's thinking about the various tools it has available and knows that it might do well to start by looking at FHIR observations. And then it's coming up with a plan for how it's going to query those observations, extract systolic and diastolic, and then run these calculations. So on its first attempt, it wrote a block of code here for looking for LOINC codes, systolic blood pressure, diastolic blood pressure, and it came up with the result that was calculated from 8 readings. So it's able to do that task in kind of one shot, and it gives you a sense of how pasting in potentially large piles that could have been hundreds of blood pressure readings, but the language model doesn't have to see them all. It can write code that summarizes them in line. So this gives you a sense of how a set of tools can make the language model more efficient in terms of being able to read just the pieces of EHR data that it needs and just when it needs to. Now, in this example, I showed you an MCP server that was running on my local computer, just reading in a local database that we fetched from my EHR provider. But things start to get a lot more interesting when these servers can be remotely hosted and can provide authorized access to a set of data that come from the outside world. So the model context protocol is being developed to support exactly those kinds of interactions, although the kinds of OAuth flows that we're talking about there are still relatively early stage, and not many of the clients support those OAuth flows in line. So I can't show you what that looks like inside of Cursor, but I can show you what it looks like inside of a testing server, or at least I think I can. So I'm going to try running one of these servers locally, and instead of showing you a real MCP client, I'm going to show you something called the inspector tool, which should be able to connect to that server that is now running, only happens to be running on my local machine. This could be running out on the internet. And when I go to connect the client to that server, it will launch an OAuth protocol. At that point, I can either select a record I've already retrieved or connect to a new EHR. And then the client will be authorized to access just the data in the record that I've chosen to connect. So in this case, if I connect it to the record I've already retrieved, I can now use this inspector tool to do things like list the available tools and then run a tool. So you can see what was happening under the hood is that Cursor was driving these interactions. It was listing the tools. It was reading the documentation for each of those tools as supplied in the model context protocol. And then it was executing those tools by passing in arguments and running the tool and seeing these kinds of results that came out. I think that we'll start to see support for this kind of OAuth workflow happening in Cursor or inside of the first-party apps from Anthropic and Claude and Google. It's still relatively early days when it comes to security on this protocol. The actual OAuth connection between the client and the server here is reasonably well specified. It's just using OAuth 2.1 with dynamic client registration. So even if the language model has never met this server before, it can register itself just in time. The really interesting security issues in this space right now are coming from places where the tools and their documentation and their outputs can start to influence language model behavior in ways that the user might not want. So there's some very interesting early attacks being shown where output from the tools might confuse the model or might cause the model to call other tools that can lead to exfiltration of information. So a pretty fast moving space right now in terms of how do you protect users. When I showed you my demo here inside of Cursor, I had it setting on YOLO mode, where I just allowed it to execute any of these tool calls that it wanted and just run them one right after another without any confirmation. But the default user experience here and in the Claude app is that every time a tool is going to be called, the user gets to sort of review and approve it. And you can see why they started with that. It feels safe, it gives the user more control, but it also puts a little too much responsibility in the user's hands to try to read this code. And frankly speaking, even if I was going to look at and review this, there's no way, particularly in this interface, that I could meaningfully review this list of code that's going to be run and decide whether it's malicious or not. Simple reason being most of it is off screen, and even scrolling to see it might be quite challenging. And indeed, some of the recent attacks here have shown examples where you, as the user, think you're seeing the full code in this preview environment, but really they've put a bunch of new lines so it looks like the code has ended, but there's actually malicious code being called underneath here that you just have to scroll down to see. So very early days when thinking about how to construct these user interfaces in a way that are actually helpful. And helping language models be robust to mitigating some of those attacks. Still a lot of quick changes here, things happening pretty frequently, and it's a space to keep an eye on. But I think this is a very promising direction in terms of allowing language models to have some agency over interacting with the EHRs. Ultimately, I think these kinds of tools will be provided and should be provided by the electronic health record systems, but it's also really important that we allow the development of these tools using standards so that even a third-party Smart on FHIR connector can start to play this role, and that can start to get things moving much faster, in some cases maybe faster than EHR vendors would be able to get there on their own. And to my mind, it's a great way to leverage these open standards. So that's it for today. Hopefully in the next review, we'll talk about how this architecture can be used as one building block in supporting a prior authorization workflow where the EHR is interacting with an outside payer to have a conversation that starts driving towards approval of prior authorization requests. That's it for now, though.